Hello and welcome to this statistics session in which we're going to talk about the binomial probability distribution and the binomial table. The binomial probability distribution is a widely occurring discrete probability distribution. A discrete number is usually a number that is the result of a count. Yes, it's usually a number that has a whole number without a decimal place, like the number of children in a classroom, the number of children in a family. So as soon as you say the number of, that normally means that we're talking about a discrete number when you are counting something. The binomial probability distribution has four characteristics. First one is there are only two possible outcomes of a particular experiment or trial. For example, a student either passes the class or fails the class. There's no other choice. If you're taking a class, either you pass it or you fail. Or whether the student is on time to the class or late. Yeah, there are only two choices. Either you're on time for the class or you're late. Two choices. Now, the second characteristic is that the outcomes are mutually exclusive. As I mentioned to you, either you pass the class or you fail. There are only two choices. So they're mutually exclusive. Either you do one or you do the other. You cannot pass the exam, you cannot pass the class or fail it at the same time. Either you do one or you do the other. So mutually exclusive is normally signaled by the word or. Or means you do either this or that. There's no joint. There's no joint. Normally, graphically, this means that you have a joint. In this case, you don't have this. You have two events that are independent or they're not happening at the same time. There's no joint. You either do one or you do another. The third characteristic is that the random variable is a result of a count, which we saw because this is a discrete number, result of a count. And the last one is that the trials are normally independent. Independent is one does not affect the other. If one student passes a class or fails a class, has nothing to do with another student passing or failing. They don't affect one another. Or if a student is early or late to a class, it has nothing to do with another student coming to the class early or late. They don't affect one another. They are independent. Now, to construct a binomial probability distribution, we need two things. One is the number of trials, which is represented by the letter n, and the probability of success of each trial, pi. The formula to calculate binomial probability is Px equals ncx pi to the power of x, 1 minus pi to the power of n minus x. Now, what is this n's and x and pi's? The first section, the ncx is from combination, is the combination formula, which we have seen in a different video for counting rules of probability. Okay, and we saw that then as NCR. Now, what is NCR? N was the total number of objects, which in this case is the total number of trials, and R is the selected number of objects. In here, we are changing R for X. Okay. If we're doing the combination probability, formula is going to be n factorial divided by r factorial n minus r factorial. Now, all of this can be avoided, okay, by using, let me move through here, by using your calculator, and you have NCR here in this section here. Now, how do you see it right there in your calculator? Now, how do you get to this one section? You do shift division to get to that section. Okay, all right. So once you do combination, then you multiply times pi. What is pi? Pi is the probability of success of each trial to the power of x, which will be given to you in the exercise. 1 minus pi to the power of n minus x. So we need to figure out in each exercise what is n, what is pi, and what is x. Once you figure all these three numbers, then you can solve for binomial probability distribution. Let's see this quick exercise. There are five flights daily from Abu Dhabi via Etihad into London Heathrow. Suppose the probability of any flight that arrives late is 0.2. What is the probability that none of the flights arrive late? So now there are four characteristics of the binomial probability distribution. First is that so one is that you only have two different possibilities or two possible outcomes when you do a trial. So here is a flight, and either the flight arrives late or arrives on time. Okay. The next one is that the outcomes are mutually exclusive. There is no joint. Either is late or on time. The flight cannot arrive to Abu Dhabi late and on time at the same time. It's either one or another, so they're mutually exclusive. Now, the other characteristic is that the distribution is each of the outcomes are independent. One airplane arriving late or on time has nothing to do with another one arriving late or on time. They don't affect one another. And the fourth one is that the results are discrete, which means that you're counting the number of outcomes. And in here is we have up to 5 flights. Up to 5 flights. So there's a result of a count. So you can have that none of them are late, or one is late, or 2, or 3, or 4, or 5. You're counting how many of these flights are late. All right, so let's check it out. So now, what have they given us? They've given us that we have a maximum of 5 flights. This is our n. They've given us that the probability of each of the flights arrives late is 0.2. This is your pi. And they're telling us what is the probability that none of these flights are late. This is your x equals 0. Now, let me dig in a little bit further. Where the characteristic says that there are only 2 possible outcomes for the trial, right? We had the flight arrived either late and then arrives on time. They've given me the probability of arriving late. Since there are only 2 choices here, if I were to ask you for the probability of a flight to be on time, you do the complement rule, 1 minus 0.2, which is 0.8. Okay? So we'll just concentrate on 0.2, but it could be that they give you the probability of a flight arriving late, and then we ask for what is the probability of a flight, or none of the flights, or 1, or 2, or 3, or 4, or 5 of the flights arriving on time. So at that point, we're looking at the opposite side. If there are only 2 choices, you also have this information as well. Okay, so let's go and look at this, where you have n equals 5, pi equals 0.2, and x equals 0. Now, we saw this is a formula here. And if we were to do it using the formula, is the probability of x equals 0 equals to, what is my n? My n is 5. C, x is equal to 0, times pi is equal to 0.2, 0.2 to the power of x, which is 0, and you write that in your calculator, minus 1 minus 0.2 to the power of 5 minus 0. You don't have to do minus 0 here, but just to test it, put it in there, not a problem. Now, in your calculator, it is super important that you put a multiplication sign here. Okay? When you're doing the combination part of the formula, and you do the rest of the formula in your calculator, you need to add a multiplication sign on it. Okay, this right here. You need to put multiplication, otherwise your calculator either will give you an error or it will not give you the right answer. If we give you a number, it will be the wrong number. Okay, so make sure that you have that piece. This right here. Oops, sorry. I'm looking for my highlighter and I'm using something else here. This right here. You need to do X. Okay, so once you do that in your calculator, you should be getting a number of 0.3277. Okay, and you see here that the one thing you want to just make sure you know is when you put it in your calculator, okay, and here you put a multiplication between the 5C0, and then you put multiplication and you continue with your calculation of 0.2 to the power of 0, 1 minus 0.2, 5 minus 0. Okay, this multiplication sign here is very important. Okay, all right. So now, here I showed you already that the combination can be accessed from your calculator by doing shift. Now, all of this can be bypassed if we use the a binomial probability table. Okay, and in this table, we'll see it in a minute. We've been given an n equals to 5. We've been given a pi equals to 0.2, and we have been given an x equal to 0. So you see the table here, and you go and look for n equals 5, and you go and look for this p here is your pi of 0.2, and then right here you have your x's. This is x equals 0. And so you have, from the table, you can get the same result, which is 0.3277, which is the same as if you do the calculation here. Okay, so let me show you the binomial table quickly. I have it open here for you, and here is your binomial table, where we have 4 pages. Okay, 4 pages in the binomial table, and you have n starting from 1 all the way to n equals 20. So when can you not use your binomial table? Well, if in this exercise we give you n equals more than 20. If we give you n equals 30, then it's no longer on the table, and then you'll have to use the formula. Okay, so we have n there, and we have probability here, which is pi for our exercises, and we have pi here, probability for 0.01 to 0.5 in the top, and we have in the bottom from 0.5 to 0.99. So now, what about pi? If in the exercise we ask you for a probability of 0.77, for example, 0.77 is not here. You either have 0.75 or you have 0.8. So if you have 0.77, then again, you have to use the formula. Okay? And each of your x's are on this side if you are for this set of probabilities, and if you're looking at the probabilities in the bottom, then these are your x's. So let's do a couple of exercises here. Okay, let's say you have n equals 9, since this is the first one we have there. Probability of 0.3, and we're looking for x equals 4. Right, so you have here n equals 9, x equals 4 is here, and pi equals 0.3 is here. So we're looking at this one column, okay? And x equals 4. You go over, and this is the number. Okay, the result for the probability of x equals 4 is 0.1715. Now let's look from the bottom of the table. Let's say, and I'm going to look at n equals 13 because that's, it's easy for me to show you. Let's say we have n equals 13. We have x equals 4, okay, and we have pi equals, let's say, 0.55. So 0.55 is here. When we're looking at the probabilities from the bottom, okay, your x is here. So we're looking at this one column here, And for x equals 4, you have, this is 4 right here. See how I used to use this is 1, 2, 3, 4. So 4 is here. So the number, so the probability of x equals 4 when n is equal to 13 is equal to 0.0495. Okay? So there is your binomial probability distribution table. And how you look, you need to find n, you need to find pi, you need to look for x. Thank you so much. I hope this helped in the binomial probability distribution section of the statistics, and hope to see you soon. Thank you. Bye.